98.1%. Adversarial learning simulate occlusion scenarios 97.8%, but they often need large diverse datasets and powerful hardware, which limits real-time usage. Let me talk. Let me walk you through the system architectures and methodologies of our proposed face recognition system, which is illustrated in this slide. Our system is divided into two main phases. As you can see, training shown on the left in purple and testing on the right in yellow. About 20 phases, we start with an input image, which is preprocessed using MediaPy to detect and crop the facial regions. We generate both original and masked versions of the face to simulate real-world variations, especially those caused by face masks. Then we apply a variety of data augmentation techniques such as rotations, flipping, zooming, brightness adjustment, and noise additions. This step increases the diversity of the datasets and helps the model become more robust under different conditions. Next, we use RedNet 50 to perform feature extractions, capturing deep and discriminative facial features. These features are then passed through our custom classification layers, consisting of dense layers to train a robust model for face recognition. Finally, the model itself into parts, the train weighs a Keras model, and the corresponding face level as a picofile. In the testing phase, the system captures real-time video input. It uses MediaPy to detect face in each frame in ResNet 50 again to extract embedding from this detected face. These embeddings are compared with the known embeddings stored during training. Based on similarity score, if the match is strong enough, meaning the score is above the predefined threshold, the system identifies the versions as shown in the right image. If the score is below the threshold, the face is labeled as unknown. For example, in these illustrations, the system correctly recognized on face with over 98% confidence, while another face that doesn't match any known identifier is labeled unknown. To better understand our proposed improvement, let's now look at the second diagram, the network architecture of our system. At its core, we use RedNet 50 as the backbone of the model. This is a deep convolution neural network that has been retrained on large facial datasets, allowing it to learn rich and discriminative features. Importantly, we freeze the ResNet 50 layers to reserve this prior knowledge and prevent overfitting during our training process. What truly sets our method apart is the custom classification head, highlighted in the dotted box labeled the proposed method. This is the part we designed specifically for robust recognitions in the presence of face masks. Here we incorporate combinations of dense, fully connected layers, back normalization to stabilize learning, drop down to reduce overfitting, and reload activation function to introduce non-linearity. These components work together to refine and transform the feature extracted by ResNet 50 into more discriminative embedding. Additionally, we apply feature concatenation, which allows us to merge information from different dense layers. This helps the model capture richer and more diverse facial representation and important feature when parts of the face, like the mouth and nose, are uploaded. In the final stage, we include two cadence layers with 1024 and 500 trail neutral, each followed by L2 regularizations and drop-down rates of 0.5 and 0.3, respectively. This carefully design ensures that the network learns effectively while remaining generalized. Lastly, we output the result through a softmax classification layer, where the number of units corresponds to the number of nodes identified in the dataset. Overall, this architecture is tailored to enhance mask face recognition. It allows the system to extract robust features, maintain high recognition accuracy, and perform reliability under challenging real-world conditions. In our experiments, we tested five configurations: no concatenation, baseline, solo middle fusion, solo diffusion, full hierarchy fusion, and the last is concatenations. We found that the best performing combinations were concatenation, dense 4 and dense 5, which gave us 99.47% accuracy. Here we saw shallow middle fusions, dense 3 and dense 4. This combination improved accuracy to 99.2% on the celebrity dataset compared to the baseline. Next, shallow diffusions combining dense 3 and dense 5 gave similar results, showing that this feature from later layer helped the model capture a complex pattern. The best performing configurations were dense 5 and dense 4 and dense 5, which achieved 99.47% accuracy. This fusion blends mid-level and high-level features while avoiding overfitting and redundancies. Here we see the training and validation accuracy over 25 epochs. Both curves increased quickly. The validation accuracy reached about 99% after just a few epochs and stayed stable. The loss graph below shows a steady decrease for both training and validations. Notably, the validation loss is slightly lower than training loss at the end, which suggests the model is not overfitting and generalized well. These results confirm our model is learning efficiently and converging quickly. This confusion matrix visualize how well the model distinguishes 17 celebrities. We see most values are along the dialogues, meaning correct prediction. Some class like Angela Jolie, Tom Cruise, and Leonardo DiCaprio have perfect accuracy, 40 out of 40 correct. Even for like Scarlett Johansson, with 79 images, the model only made one mistake. This proves that our feature concatenation strategy enables the model to accurately distinguish mask face, even among many identified. Here we try fusing on 3 layers, then 3, then 4, and then 5. Thus, it also performed well, 34%. It did not surpass the similar dense 4 and dense 5 combination due to possible redundancies. Here, this table summarized on results from the celebrity dataset. We start from a baseline of 98.5% and prove strategies later combinations reach up to 99.47% using then 4 and then 5. As you can see, in the concatenations, we have 4 incorrect images and 754 correct images. This is the result of celebrity datasets, and we have the experimental result with different dense layer architecture of our datasets. We also evaluated the model on our dataset collected from brains. Even in real-world uncontrolled conditions, the system achieved 96.05% accuracy, proving its robustness outside benchmark datasets. We've also built a demo that runs its real-time using webcam input. It can detect and recognize math phase with like confidence score. Uh, in conclusion, our research presents a robust and efficient framework for math phase recognition by integrating media pi, resonancy, data augmentation, and feature fusion. We achieve state of the art performance. In the future, we aim to optimize our model for each device and further improve performance under several applications. Thank you very much for your attention. That's all.
Thank you for the presentation. Any comments from the audience online? I mean, okay, no specific question. I mean, let's go to the second presentation. Robust blueberry leaf disease detection and so on. We have the presenter here. Okay.
Can you repeat?
You will present, I mean? We hear some music, which is good.
Hear me?
Okay, please share your screen and start with the presentation.
Okay.
Good.
Can see my
Okay.
screens, right?
Hey, it
Okay.
works. We can see the presentation. Yeah, we
Okay. Okay. Thank you. Hello, everyone. Today, I would like to introduce about our paper. So I'm Ken Nguyễn Hoàng Kha from FPT University. Today, I'm going to introduce about our paper, robust blueberry leaf disease detection using transformer based and local concise future methods. So our content in have five part. The first one in introduction, related word, the report methods, experimental result, and last one in conclusion. So the first introduction, we have three problem. First is diverse land species, climate driven system variation, and new disease in unfamiliar region. So the ACID solution is last vehicle SYM KNN decision tree. And in the deep learning, we have CNN running population arity. And in LBP, we have effective in texture analysis for disease spot. And in transformer, we have the assist solution is emerging in vision type with attention-based learning. So our solution is propose a novel methods combining CS, LPP, concise similarity based local binary pattern, and we base on transformer based encoding, and we using Zolo VA for detection, and the role is improve the robustness and accuracy in uncontrolled environment. So the key contribution of our contribution is LVP descriptor is capture local texture similarity, and hybrid feature is combine CS LPP and linear projection and positional encoding. So in the YOLO VA iteration for stable blueberry leaf disease detection. So in the dataset and evaluation, we use land leaf disease dataset, and we have another dataset that is custom blueberry dataset from Cần Thơ, Vietnam. And we saw strong performance even under a challenging real-world condition. And next one is related word. In AI for blend disease detection, review assisting method, we have uh, AI methods are why use monitor blend disease and improve agricultural productivity. So the traditional approach, we have pre-processing techniques, color space conversing, filtering, history evaluation, data augmentation. So next one is deep learning application. The transformer learning, we have efficientness. Other technique is GLCM and SYM for ref and means lead entropy, SYM KNN for tomato. So in challenge and identify, most model perform well in control condition, but in noise and complex environment is not work right. So our research direction is introduce a novel local director. So combine linear embedding and positional encoding to improve the accuracy and so robustness to in the real world condition. So that is the table of survey our survey of assist land leaf disease detection paper. You can see in the picture is table. Our report methods, we have two sides. The first, we have the split image and we give it to linear project pattern. Then we give it to yellow VA to detect is disease or not disease. So our report UCS LPP, we also split that and give it to linear projection of pattern, and then we give it to yellow VA to detect is disease or not disease. So you can see in the picture our ropo. You can see the original the noise and what original LBP is the leak is not clear than our ropo methods. So that is why our CS LVP is better. So that is main CS LVP formula and also a binary function and the structure vector. That is formula of this. So that is a past embedding processing. Yep. And in experimental result, we have the that is a sampler of blueberry leaf dataset from Cần Thơ, Vietnam. So that we capture that introduction about datasets. We use the first one. We use land leaf DC detection dataset. Land leaf DC dataset. So from around is A7 ATK 87K and image, and we have 38 classes, healthy and disease. And with this is 80% for training, 24 validation, and the test set is 33 image classes. That is a symbol of our class. We have our class is blueberry healthy class. We have the name of that, and we have also a custom data set from Cần Thơ University, Vietnam. It captures local and focus on blueberry disease. So augmentation, we have augmentation technique applied for REA around 10K sample and 7K for training, 2K for validation, and 1K for testing. So we apply the Rosen noise for that to similarity in the real world difficulty. That is metric of evaluation and algorithm for comparison. So in the result, you can see in the normal condition we have like the better a little bit than the we compare with for assist methods system method. We have YOLO VA, YOLO VA, YOLO V5 LPP, and YOLO VA LPP also with efficientness. So we have a better a little bit than system assisting methods. So that is a normal. That is difficult the condition. You can see our report methods is have are higher than assisting method. Like in the precision, we have better than 5% than YOLO VALGP. Also with accuracy, we have always have a higher more than the assisting method. So in the conclusion, the key contribution of our report is to show a CS LVP methods combined with linear embedding position encoding, and we achieve a robust feature representation, demonstrate competitive performance under normal condition and non-condition environment. So we have a limitation, and so we have in reprocessing time because we use a large number of input feature so during training and inference. So in the future world, we use a multimodal fusion technique to improve the accuracy efficiency for disease detection. So that's all of my presentation. Thank you for your listening. We are open for question.
Okay, thank you for the presentation, Guyen. Any question from the room? You can turn on the microphone if you have a question. Okay, Nguyen, thank you.
Yeah.
We can go on. The third speaker is who is the third speaker? Nguyen. Okay. You can turn on the presentation. Nguyen, this should be this. This one. Okay. Okay. So no, Kin Trang
Yeah,
is the presenter. Okay.
yes,
Okay.
I go
No
into
need.
present. Yeah.
Okay, you can start. Thank you very much.
Okay, thank you. So, good afternoon, everyone, and thanks for joining me. I'm Kian, and now I would like to present our work, which is the HG-YOLOS models. This improve the tumor detection with the PP-HG-net and the global attention mechanisms. So, my presentation is consists of four main parts: introduction, proposed method, results, and conclusions. So, let's get started with the first one, with the introduction and background. So, cancer is one of the leading causes of death globally, and the brain tumors, whether it's primary, and also pose the serious health risk due to their potential to impair vital function. So, for the MRI, so it is remain the gold standard for diagnosis, and yet it's early for tumor can be too subtle for manual detection. So for the overall detection, we have the deep learning technique, particularly for the CNNs, have the revolutions in medical imaging by automatic complete the visual analysis. And the YOLO architect stand out for the speed and also the accuracies. Besides, the uses of the models also favor for apply in the medical field and applications such as the tumor detection and also the mass detection, van detection, etc. So recently for the YOLO version 9 to YOLO version 11, so it's also demonstrate the dramatical improvement in terms of speed and also accuracies. But this benefit for the application for the brain MRIs also detect the mass. And however, due to the YOLO series are focused on the general objects and still not very optimized for the medical image. So that's why this leads to that we build on this enhance for the tumor and also to upgrade the performance of the YOLO-based model. So this leads to our the task we focus on answer the research question that is how can we improve the performance of YOLO-based models in MRIs for tumor detections. So our primary research question will concentrate on the enhancement of the YOLO-based models for better tumor localization in the MRI scans. And by replacing the backbone of the original YOLO and replaced by the PPHG-net and also incorporating with the GMA, that means the global attention mechanisms. So we hypothesize that's improved accuracy and also the robustness. Our objectives include the testing on the benchmark dataset and also the component level validation through the ablation studies. So for the proposed method, so this is our proposed models. So our architectures we built on the YOLO 11. So we have the backbone, neck, and also the head part. And the PPHGNet will serve as the new backbone, allow the model to capture the five grand features, and also the SPFF, that means the spatial parametric pooling fast model. So it's iterated after the PPHGNet, especially with energy to extract more feature from various regions of image at multiple scales. And also for the core state partial spatial attention, this means the C2 PSA. So it's applied to provide attention mechanism at the end of the backbone part. And for the neck, we will use the rapid normalized cross-state partial with the efficient large-scale kernel attentional network. That's mean the RAP-NC SP11 in here. So this is used to replace the original, the C3K2 block, and then in the net part, and also optimize with efficiency without losing the accuracy also. And the GMAs, that's mean GAM, so you enhance the detection precision across different object scales. So these improve aim to detect even poorly the contrast of tumors also. So for the REP-NC SP11, so this is the lightweight and also powerful neck model that's captured the deep features without redundant computation. So this initiates the inspired from the architecture combined with the cross-state partial network and also the efficient layer aggregation network. So as we can see in here, it can split the features and also process them independently, and then they merge them later. So this will ensure the both diversity and also the computational cost when we processing. So for the main backbone, that means the PPHG net, this is designed for both deep features and also efficiency calculation. So the architectures of this network is employs a learnable downsampling layer, that means the LTS layers, and also from the VOV net to preserve the spatial features while reducing the combinational cost. And this employs the hierarchical structure to extract the feature which facilitate the effective handling and also complicated image data. So the main core of this is to allow the network to understand the local and global page patterns and stacking deep-wise convolutions. So this is show the key operation inside the HG blocks. This multi-layer architecture enable the network efficiently integrate element at the multiple levels. This will aggregating both deep and also the general patient patterns data. Each convolutional layer transforms the feature map using the standard of phi transformer to the non-linearity. So the feature maps from each state can get through the normalization process, and also the network can combine a multiple scale feature using the concatenations. So finally, with the SE block in here, we can adapt and also recapitulate the channel-wide response using the global average pooling layer and also the two fully connected layers. So of course, we also have this optional that we provide a skip connection in here so that we can strengthen the feature that we addressed before. And for the global attention mechanisms, so this enables the model to prioritize the region that and the channels that are likely to contain meaningful information. So this especially useful for medical imaging, where the small variations and also intensity can indicate the pathologies. So in GMA's GAM, this means the channel attention can be computed using the multiple layers and also apply on the global discriminator, generate a set weight for each channel. And also the spatial attention can refine the focus using the convolutional filters and allow the model to highlight the spatially relevant features in here. So returning to the experiment and also the result part. So in this study, we work on the BR35H dataset, which stands for the Brain Tumor Detection 2020 dataset. So this totally comprised approximately 700 MRI image in the JPEG format and also from the diverse patient demographics. And the data have the wide variety of tumor form and stage. So we apply the ratio for training and validation is 80/20. So that means 560 image for training and for 140 for validations. So for the setting, the image setting, we implement on the computer with the 12th generation with the Core i7, and also with the GPU. This is RTX 3090 with the 24 gigabyte VRAM. And also for the OS and framework, we will use the Ubuntu and also the Python version 2 and CUDA 11.7. And the training option in here, we also rescale the image to the 640 per 640, and also the epoch we set at 300, batch size with 32, and optimizer we use the Adam optimizer, and also the initial learning rate we set at 0.001. So to give the comprehensive look for the learning ability, so we can see that this figure will show the training progress with 4 evaluation metrics in our models. So overall, almost the value reached the saturation point and also less fluctuated after 200 epoch, and only the map 50 until to 95 reach around 0.7, while other metrics is increased over 0.9. And to conduct the quantitative and also qualitative experiments, we compare with the YOLO version 9, version 10, 11, and also for our study. So as we can see in the table number 1, so it's clear that our proposed architectures which integrate with the PPHG Nest and the GMAs achieve the good performance, and the HG-YOLO achieve the highest value compared to other models. So for the visualization comparisons, we can see that for the first instance in here, while the YOLO version 10 and version 11 have duplicated error detection, but only version 9 and our proposed model detect correctly the mask. And for the second instance in here, we have YOLO version 10 and version 11 fail to detect the mask object, while our other models can identify the model correctly. And for the third one, samples, we have the YOLO version 9 is failed to detect, but other is able to detect correctly. And also for the final case, only our proposed models show the advanced detection by placing the correct bounding box, and other ones have one wrong detection for the smallest mass in here. So to carry out the selection of attention module, so the table 2, which will show the performance comparison, different attention approaches, such as the coordinated attentions and also the triplet attention. So for the GMAs, as we can see in here, the GMAs consistently outperform the CA and also the TA almost for all metrics, especially the GMA achieved the highest precision at 0.934. So this indicates that the GMAs provide a more accurate distinction between the tumors and also the non-tumor regions. So for the bounding box optimization, we conduct the comparisons for different type of IOU loss functions. So overall, for the CIOU, as you can see, that is achieved almost the highest value among the metrics compared to other methods. And also, although the GIOU record highest at the map 50 to 95 of 0.732, but as we can see that the CIOU still reach the overall balance among all the metrics in C. So to conclude this presentation, so our HG-YOLO bring together the latest version innovation for the backbone and also attention mechanism to the improved tumor detections. So the combination of the advanced feature extraction and focused attentions on the relevant features allowed HG-YOLO model to accurately identify the even very small and low contrast tumors. So for the future directions, so we may include the cross-modality application and also optimizing the model for the lightweight deployment. So this also concludes my presentation, and thanks for listening.
Thank you for the presentation. Uh, does any question comes from the room? Okay, thank you. I think we can move to the fourth one.
Okay, thank you.
Okay, thanks. The fourth paper is multimodal approach for canine dermatological and so on. Have we got the presenter connected? I think no. Nguyen, probably you are the author of this paper or not? Or I am wrong. Hmm. I think that one of the author is the same of the first and the second paper. Any reaction? Sì. We have to discuss now multimodal approach for the canine dermatological and ophthalmological disease diagnosis using YOLO version 1.1.
Is there any presenter for this paper?
So, thank you everybody for participating and contributing. I will close the session and we go on with the program of the conference. Thank you. Thank you very much.
Thank you very much.
Thank you, really. Thank you.
Yes.
Is this the room to present the paper? Oh, sorry. Oh, excuse me, Mr. Simon.
Sorry?
Oh,
Can you
so, sorry, I didn't really hear when my paper was called earlier. My paper is multimodal approach for chemistry, dermatological and ophthalmological. And I thought the presentation would start exactly at 3 o'clock. I joined around 2:40 p.m. After finish some work. It's possible for me to resend now or reschedule. So
but you want
sorry.
to present in this session or? I think that you need to ask to Osvaldo, send an email to Osvaldo Gervasi, and because this is a different session.
Uh,
If you understand well, because I can't understand well what is the
yeah.
problem.
Yes. Sorry.
Yes. So if I understand well, you have to present in the previous session, right?
Yeah. I was scheduled resent in 3 o'clock, and I missed it.
You miss it. Yeah, I understand.
Yeah.
But please send an email to Osvaldo Gervasi and ask if you want present in another session, but tomorrow. And I don't think in this session because this session is a different topic. So I don't think it's possible. I'm the technical assistant. I'm not the chair, but I think
Oh, so
just
sorry.
ask Osvaldo. Just ask Osvaldo. I also say him there is a problem and we just manage it. But I think you have to present tomorrow in another session. Is a general track.
Also, after session or tomorrow, I can resend after session. It's okay.
Just a second. Just a second.
Oh my God. Oh,
Good
sorry.
afternoon.
Wong, can you hear me? Wong, sorry. If vuoi partire, io scrivo che siamo pronti.
Sì.
Ok.
Yes, next seconds so Ok, grazie. Grazie. Okay. Good afternoon, everybody, and welcome to this session on of the geographical analysis of modeling spatial statistics. Okay, we have ready to start with this mixed session. We have a part of the contribution in presence, and the part will be mixed and the part virtual. So I would propose a little change of the order. So because so we could have at first the presentation that is in presence by Veronica Karajeva, and then continue with the other orders so that we can have a smoother, let's say, organization of the presentations in presence at and the distance. So I would therefore start with Veronika Karajeva, Piotr Ferner, and Mariusz Korstek. I don't know if I did pronounce your name correctly. If I didn't, I really apologize for that. So please, Veronika, whenever you'd like to present your paper on assessing local human development in Poland, insight from 2010 and 2023. So if you'd like to join the desk, you can present your paper, and the floor is yours. Okay?
Yeah, thank you very much. I'm used for every pronunciation, and I'm completely okay with this. Yours is perfect.
Thank you.
I'm living, abroad for almost all my life, so.
Okay.
So, good afternoon. I'm going to present the research titled Accessing Local Human Development in Poland, which is conducted with my senior colleagues, Professor Piotr Ferner and Mariusz Borczek. I'm a PhD student at the University of Warsaw, and we all present the Spatial Information System Laboratory on the Department of Geography and Regional Study. The structure of my presentation will be really simple. I will say a couple of words as an introduction, later go through methodology and the results. Oh, it works. So, what is Human Development Index and why does it matter? Quantifying and measuring human development in different contexts is a very challenging task. And perhaps this is one of the reasons why Human Development Index gained such popularity. The Human Development Index was created to emphasize that people and their capabilities should be ultimate criteria for accessing countries' development, not only pure economic criteria such as GDP, for instance. So the Human Development Index is a composite measure developed by the United Nations Development Programme to assess long-time progress in three fundamental dimensions: health, income, and education. And the health is measured is life expectancy. Education is measured for this index as years of schooling, and income is measured as GDP per capita. And the geometric mean is used to synthesize this as a composite index. So on this slide, we can see the distribution of Human Development Index according to the latest data from this year. And by this visualization, we can guess that it's rather valuable tools for comparing development levels across countries and tracking progress over time. And it's really widely used to compare development between countries, helping policymakers access global inequalities. However, Human Development Index is not designed to reflect disparities within countries, to capture local development dynamics. So Human Development Index, the same such as other national level indicators, often hide regional disparities. And local governments need more granular data to inform policies, investments, and social programs in their countries. And this gap is addressed by the local Human Development Index, which adapts the Human Development Index framework for subnational units such as counties, communes, and in some case studies, even households. And by this, it offers more detailed and context-sensitive insights that support targeted responses to local development challenges. And this is really a very vast body of human development, of local human development research, but there is still no uniform methodology to study LHDI, because every country is operating based on their local granular data and local contexts. So the first local Human Development Index for study was implemented in 2012 and based on data from 2010, and it aimed to provide comparable HDI-like indicators to county level. County level in Polish powiat is an administrative unit that is one level below the NUTS 3 Eurostat unit. And this report firstly introduced proxies for all three dimensions of Human Development Index adopted for locally available data. And the formula looks rather similar. It's based on three main dimensions, classic dimension of HDI. The indicators are normalized and combined using geometric mean. And the difference is in index construction compared to the country level HDI is that each sub-index in local Human Development Index in Poland is also a composite metric and based on a set of indicators, variables, making the calculations much more complex to compare with Human Development Index that we used to see. The replicating this approach in this year, based on data on 2023, it's the most recently available data for Poland, served us to track changes over time and assess the impact of recent major disruptions, such as COVID-19 pandemic, first of all, and the escalation of the war in Ukraine, which for sure influenced societal values and the social perception of Poland. And repeating the study allowed us for temporal comparability while maintaining the same indicator how it was constructed in 2012. So we haven't changed anything in the methodology for this reason. We have started our analysis with a very simple statistics like period t-test and box plots and scatter matrix plots. And our first insight was that there is no significant change in overall local Human Development Index between 2010 and 2003, which is very worrying because given that this is a 13 years period, considerable growth could have been expected. So there is no any growth and significant improvement in wealth and education indices, and statistically insignificant but still notable decline in health index that offsets the growth in wealth index and in education index. Another interesting conclusion was that although the average parameters of local human development index has not changed significantly, we observed polarization. And the counties with low levels of human development in 2010 worsened their scores nowadays, while the top performance one maintained a high level. And the greatest variation concerned the health parameter component. And it's already visible on the scatter plot matrix. These disparate indices are widely disparate, mostly related to health indicator. So the next step, we calculated an absolute simple difference between the parameters in 2 years, in 2010 and 2023. And it looks as the follows. On this map, in many cases, we can observe characteristics bagels around the metropolitan cities, illustrating the increase of the index in the city's outskirts. We interlink this with the continuing suburbanization in Polish conditions, which is progressing year by year. Our next step was a cluster analysis, and we created a cluster classification of counties with similar local development values, and trends were identified. So there are 3 main groups. Green group referring to low development, red group referring to high development, and all the others are in between, let's say. So, and in the red group, we can see that the parameters are stable, and all in other groups there are the clusters that are decline and the clusters that are increasing. And red clusters with the letter H for high represent units with consistently high levels, and the letter W, worse, represent units with the lowest parameter, and U and D stands for up and down respectively. And this is a spatial distribution of the clusters. In the cluster map, it's clearly indicated that a high level of human development is characteristics of the largest cities and metropolitan area. On this chart, we can see that counties with the low indices in 2010, in many cases, even lower their values in 2023, and meanwhile, counties with the highest indicators remain relatively stable. This chart presents the distribution of sub-indices. Health index exhibited the most significant change among all 3 parameters, and this we can see that this distribution is, let's say, chaotic among different countries, and spread is observed across all of them. Education parameter exhibits lower dispersion, and this parameter contributed to the observed decline within the lower performing clusters, CCDU and LDL. And wealth parameter, the last one, exhibits the lowest dispersion among all 3 parameters, and it's a noticeable decline is observed among the wealthiest counties as well among the poorest one, although the general trend remains positive. So this is a comparison of rural and urban counties. They look rather similar. Perhaps with the difference that the most of the red points corresponding to high values are on the chart of urban clusters. So in the next part, I'm going to show without a very detailed explanation the spatial distribution by the bivariate analysis of particular sub-indexes. The detailed analysis probably would be more interested for local practitioners, and for academic purposes, I just want to emphasize the similarity and the differences in the distribution of 3 parameters. I will switch to make it visually possible. So this is a health parameter, education parameter, and wealth parameter. Even visually, we can see that the distribution really differs for particular sub-indices. I will repeat to show this red and blue clusters to show that actually this red zone symbolizing the top performing counties remain more or less the same places, while this blue one representing the lagging behind areas are changing for subparameters. And these red clusters, these are actually Warsaw metropolitan area, Krakow, Silesia, and Gdańsk, consistently belonging to the hot outliers and overall local human development layers and its component, while bottom outliers are represented by different areas for particular domains. And it suggests that this lagging behind might be different reasoning underlying causes. And for instance, this slide presenting the distribution of the wealth component, the east and west divide is evident, reflecting the evidence of the Second World War and the historical division of Poland. It's consequently shown in all the study about the wealth distribution in Poland. At the same time, in all three subparameters, we can see that the metropolitan areas, the core centers, have the highest values. So the urban-rural division is very evident on each stage of the research. And the key takeaways from this study is that the overall Human Local Development Index shows signs of polarization across continent in the period between 2010 and 2023. And this pattern is very concerning because it reflects an increasing inequalities that might result in the right access to resources and services and opportunities. The educational index is the most stable one with a linear pattern and indicated steady progress in most of the regions, while health index reveals divergent trends with clear polarization and possibly reflected uneven healthcare access or local healthcare shocks. We interpret this in connection with the pandemic period from one side, and from the other side through the length of the well-known continuous problems in Polish healthcare systems. And wealth index follows a nearly linear trend, but with distinct outliers. Some counties with very high wealth levels emerged as hotspots. And in general, the study does not indicate a clear crisis-related downturn. And our general conclusion and the local human development index research offers a valuable lens for monitoring human development within countries on subnational level. And the Polish case demonstrates the importance of continuity and consistency in using composite indices over time. Local Human Development Index might be used as a powerful tool for regional planning and resource allocation. And we are going to focus on our future work on quantifying the relationship between Human Development Index and the stage of urban development, because from this stage of research, it's evident that it's correlate. So we are going to quantify and measure it better. And consider the smaller special units for analysis. We are thinking about the counties. It's one level below the counties. And the general findings suggest the need for targeted health investments and continuous support for education equity and addressing wealth concentrations through inclusive policies. Thank you very much.
Thank you very much. Thank you, Veronica. Thank you for your presentation. Compliments for your research. You can stay. Here we go. Has there any question from the audience? Okay.
Thank you very much. Congratulations on this study. My question is on spatial analysis units. You recommended that smaller spatial analysis units are better for understanding. For the pattern, spatial pattern, what sort of analysis unit you recommend? I mean, you say about smaller.
Yes.
Just I'm not sure whether you are referring to the spatial resolution or the geographical extent of the territory. Can you please clarify?
The problem of spatial unit is a universal problem in geography, and I think that the best approach and to start with one unit and continue with another one, because on every scale you can have another result, and each of them will be very valuable. What you can see on, for example, county level shows the general dynamic, but if we go through 1 year ago, one scale down, we can analyze, for instance, metropolitan area, and I met in some research only even households and the smallest units, so it provides completely another scale of research. So I think that there is no one good answer for this question, and comparison takes advantage. Yeah.
So just to follow up on that, I think what you are referring is this modifiable area unit problem. In geography, it is a persisting problem, which some researchers think that it is solved. Some researchers think that still the problem is persisting. As you said, when we analyze the data in one scale, we get one information. When we aggregate those data sets and analyze, we get another information. Right?
Yeah.
So perhaps you are referring to that.
Yes, this is what I meant. Thank you for concluding.
Other questions? Other?
Yes, I have a question. Does your research identifies the effects of the war of Ukraine in some manner?
It was our attention, but as a result, we have found to be it conclusive, we really need to have more than two temporal points, the 2010 and 2023, because this period is really large, and we cannot actually reason in what was the matter of changes or lack of changes.
Thank you.
Okay, I got a question. Well, top question is a couple of very brief observation, because I don't want to take time to other colleagues. First of all, I found your research very interesting and promising. So my compliments for that, because it is yes, it is hard to find to apply that kind of index at the local level, and as you correctly mentioned, there is a MOOC problem that it's quite hard to tackle actually, because of the availability of data to administrative units or statistical units. So in any case, what you showed us, it already presents some of the local disparities, and therefore they are quite evident. Just one point. At one point, that is a suggestion, and I'm completely with you that one of the points that is worth investigating is to better understand what are the dynamics at urban and peri-urban level, because it's something that is quite interesting in observing. And stressing that, I think that it would be useful in the maps that you created to highlight what are the urban areas, because for a non-Polish, it's quite hard to detect what are the urban areas you are referring to, and nonetheless, I
very few names.
Yeah. So, or also, it would be interesting to point out let's say, the limit of the metropolitan area or the unit, just to have an observation about the area you're referring to, and. If you can go very briefly to one of the first slide that you presented, it's just possibly a small
one of the first
graphic. If you go to a little bit further, well, actually, okay, here, okay. About the colors that you've chosen, what the red one implies. Does that imply that you have an improvement or a worsening?
It's improvement.
improvement. So here
it's changed in indexes, so
okay.
it's 15 up to 23. It's
okay. Here maybe I would suggest to invert the ramping. Turn the scale around. Yeah, because the red generally indicates something bad, and the blue or green colors generally. So apart from that, okay, it is readable and it is consistent with what you presented, but just for a you can intuitively perceive it a bit better if you change the color scale.
Thank you for this suggestion.
That's it. Okay, Veronica, thank you very much for your presentation and all the best for your research. I guess that this is your PhD research or something. Yes. Okay. So all the best for your research, and of course, please feel free to contact the German mod community if you need any help or any support. Okay. So I will move to the second presentation. It is by Dahir, Mohammed Ali, and myself. I don't know Dahir if you are connected. You can actually. Yes. Okay. Hello, Dahir. Good to see you. Okay. If you please can. Okay. Perfect. Share your screen and the floor is yours. Please, 15 minutes of presentation, and you can go. Okay. Thank you.
Okay. Good afternoon, everyone. My name is Zahir Mohammed. I'm from Al-National University, and I'm honored to present our paper, which is the impact of agricultural productivity on climate change in East Africa community, co-authored with Professor Giuseppe from University of Trieste. We selected the topic, this topic due to its critical relevance of intersection of sustainable development, environmental science, and conceptual analysis. The first contents of our page.
Dahir, sorry, can you hear me? Can
Yes.
you please switch your presentation to full screen? Because it's easier to. Okay.
Okay. What about right now?
Not yet. No, not yet. Maybe because if you share a program and not the full screen, maybe this is the problem.
Okay, we'll try. What about right now?
Okay, no. Unfortunately.
Is it okay right now?
No.
No, we can't see in full screen. Try to put full screen. Okay. Otherwise, you can go in this way. Yeah.
Okay.
It's you can go. Yeah.
What about right now?
No, it's the lower right. Lower right there is near the minus symbol. Yeah.
Okay.
No. If you go on let's go on.
You can go on. Yeah.
Oh.
Continue to your presentation, please. Thank you.
Okay. What about if I send it to the BBT in the chat? Maybe.
No, there is no problem. You can go on.
Okay. So our research explores how agricultural productivity in East Africa affected climate change, aimed to inform suitability policy in critical region. Then, when we are talking about why we do this study, the main goals of our study is to assess the impact of cereal productivity, analyzing long-term climate change trend over 3 decades. Also, it suggests that how agricultural is a backbone in East Africa. Then the research considers to answer the following research key questions. First question is how climate variable like maximum temperature, rainfall, and carbon dioxide affects cereal productivity in East Africa. The second question is, are there any significant difference impact across the countries, specific country effect? The third question that our research answers is that what is the dynamic relationship between vast cereal output and climate factors? The fourth one is which model is appropriate, fixed model, random model, or dynamic? Which one is the best explains this relationship? And in the world, when we are talking about climate change, is a critical phenomena that affects environment, economics, and community worldwide. Also, it affects to the regional impact on East Africa. The rural livelihood at risk from crop failure and livelihood loss due to the increase of droughts and eradicates rainfall threatened by food security. Our study also considered regional climate challenges. Since in 1991, the regional has experienced notable rising in temperature, on average about 0.3 degree Celsius per decade. As long as this one trend has been increasing in regularly rainfall pattern and extreme weather events such as floods, droughts, which disrupted farming cycle and food production. Some countries in East Africa, East African community, including Somalia and South Sudan, facing particular critical exploration due to their fragile ecosystem and social political challenges. Also, when we are talking about East African communities, there are regional integration organization consists of 8 countries, like such as Kenya, Uganda, Tanzania, Rwanda, Burundi, South Sudan, DRC, and Somalia. And it's estimated that their population over 300 million people, which their economic is dependent on agriculture, mainly contribute to the GDP and employment source of that countries. When we are talking about also the area of our study, we collected the data from different countries. We focus on only 6 of the countries, of that 8 countries. The other 2 countries is missing, some data are unavailable. Therefore, we use only that 6 countries. The first 3 countries are original members of East African community countries, which is Kenya, Uganda, and Tanzania. And in 2007, Burundi and Rwanda joined it, and later in 2003, Somalia is joined. And data we collect from the climate change is NASA power. We collect data maximum temperature, precipitation, and soil radiation. And agricultural data we collect from World Bank for cereal yield and carbon dioxide. Time series from in 1990 up to 2020. We use Stata and GIS to analyze this paper. We use dynamic data we use dynamic modeling data by using generalized method movement by making first differencing, and our dependent variable was cereal yield, while independent variables was maximum temperature, precipitation or rainfall, carbon dioxide, and soil radiation. Based on our outcome or result, the first thing we test the model, we make a fixed effect model result. And our model explains 40% of within countries variation of cereal productivity. Overall, significant of model. because B value is less than 0.01. Regarding for the climate variables, maximum temperature shows negative effect of cereal productivity within coefficient of approximately negative 0.7, which suggests that higher temperature tends to reduce cereal yield. This is effect of significantly. Rainfall has a small negative effect of coefficients, but it's not statistically significant in this model. Carbon dioxide level has been positive and higher significant effect on cereal productivity with coefficient of 0.2, indicating that potential fertilization effects on indirect to other benefits. Also, solar radiation also shows that there is a significant negative impact of coefficients around negative 0.4, which implies that increase in solar radiation may reduce of cereal yield in the context. On the other side, we test linear regression result. And this model based on 192 observations explained by nearly 48% of variation in cereal productivity. And R square is showing that it's strong and overall significant, which is less than 0.5. The coefficient indicates that maximum temperature has significant positive effect on cereal yield within coefficient of approximately 0.9. This suggested that within this model, higher temperature are associated with increasing cereal productivity. On the other hand, rainfall also shows significant positive impact of cereal yield within the coefficient of 0.3. On the other hand, when we are considering for it shows that there is strong effect of coefficients of around 0.2, revealing that potential fertilization effect to the high atmospheric of carbon dioxide. Conversely, solar radiation has significant effect on cereal output, approximately of negative 0.2. Then we make diagnostic test. First, we tested Hosman test. The Hosman test was performed to choose between which one is fit for our model, fixed model or random model. The test strongly rejected the null hypothesis, which is p-value is less than 0.5, indicating that the random effect of model is inconsistent. Therefore, fixed model is appropriate of our choices, comparable to the random effect model, as it counts for correlation between unobserved specific context factors. Specific factors, explanatory variables ensure more reliable estimators of impact of climate change overall cereal productivity. Then we test test summary. We test the significance of heteroscedasticity across the countries, and our p-value is less than 0.5, which is our p-value is 0.01, which is less than 5%, and it's significant. It means that the error variation difference between groups and the standard errors are used to ensure reliable for the regression results. Then we test rule test for autocorrelation summary. We applied this to check first autocorrelation test in our panel model data. The null hypothesis ensures that no autocorrelation test, and our p-value is 0.02, which is less than 0.5, and we rejected the null hypothesis, and indicating that the presence of autocorrelation in error, this can be rejected, that errors on one time period are correlated with the errors of previous one. So we rejected to the null hypothesis. The final part, we test the dynamic panel model test. for one-step differentiation of GMM. This test, the data we use is 6 countries, and we have 174 observations for 29 per country, for each country. The number of instruments we use was 163, and then our p-value is 0.003, which is less than 0.5. It means that our model is jointly significant. And then we test for autoregulation test. And first autoregulation test we got no autocorrelation at first order was passed. Also, we test uh, overall significance of restriction of the model, and our instrument appears for valid. And then the lastly, based on our research, we recommend the following policies to develop climate resilience. We develop climate resilience critical crops to invest heat and drought tolerant variation and strength farmers and research cooperation of adaptation of it. Also, the second, we promote climate smart practice by encouraging agroforestry and conversions to expand the farmer training and across to the sustainable tools. We establish integrated water system. The third one, we need to establish integrated water management system, improving irrigation and water efficiency, and supporting local water resource governance. And the last one, we recommend to enhance monitoring and early warning system by using integrated satellites and field data of real-time analysis and building open data platform of sharing these responses. And that's the end. Thank you.
Okay, thank you, Daniel. Thank you, Daniel.
And I'm sorry for the BBT problem, for the technical problem.
No worries, here. So thank you for your presentation. Is there any question on this presentation?
Okay. Just to comment to say it was very clear what you presented, and I would just encourage you to carry on through the goals that you mentioned in the final slide.
Okay. Okay. So yeah, that is part I can add this. This is part of a research actually that here started and tackled this research and well, I would like to add that here I will be spending 3 months period in Trieste, in my home university, as a visiting scholar, and within a collaboration that we are having with this Mali National University, and we keep our fingers crossed because here is also applying for a PhD in our home university, and so we will be working together from July on, as soon as his visa will be operational and capable of being in presence. So yes, he should have been here actually. We were planning to have him here in presence, but yes, the Italian embassy times didn't allow that. So okay, but in any case, it's a good start. Okay, and here, thank you very much once again, and we can move to the second part of the session. I see Vladimir connected with a paper from Vladimir Alacon, Paul Mikel, and Ruben Alfredo Alvaredo, hydrodynamical model of the Mississippi Sound, USA. Vladimir, the floor is yours.
Thank you very much. Thank you. Can you hear me well?
Yes, we can.
Yes.
And let's try the presentation mode.
Works. It works.
Yes.
Yes.
Is it okay?
Yeah, it's okay. Yeah.
Now I am gonna use the cursor. I am trying to find where is the. Give me
It's
one
one
minute.
up, pointer up.
options. Yeah. Okay, laser pointer. Yes, because I will need that. Thank you very much. Good afternoon, although here it is good morning. I have organized this presentation talking first about the geographical location where this study was undertaken, so you can familiarize with the geographical setting. Then I will state the problem and kind of justification for the study. I will briefly talk about the data sets and the code that we used in this study, and finally the results and conclusions. The Mississippi Sound is an area of the northern Gulf of Mexico that is between the states of Louisiana and Mississippi in the coastal zone. There is a small portion of Alabama, but most of the Mississippi Sound is in the state of Mississippi. Nevertheless, this sound, besides the connection that it has with the Gulf of Mexico, that is the ocean, it has a connection through a natural canal called the Rigolettes. It has a connection with Lake Pontchartrain. Lake Pontchartrain is a natural lake that is close to the city of New Orleans. And in one side, in the western side of this lake, there is a hydraulic structure and a spillway. The name is Bonnet Carré Spillway or Bonnet-Carré Spillway, depending on the pronunciation that you want to use. And this is a flood control structure that opens only when the Mississippi River has excessive flow. And to avoid flooding in New Orleans, the flow is diverted to Lake Pontchartrain. Of course, Mississippi River carries fresh water. The fresh water is diverted to Lake Pontchartrain, and from Lake Pontchartrain through hydrodynamic transport, fresh water and whatever the lake contains travels to the Mississippi Sound, affecting the water quality in all of the Mississippi Sound. And since many economical activities depend on the Mississippi Sound, then the openings of this hydraulic structure have strong consequences in Mississippi. So several rivers drain to Lake Pontchartrain and also to the Mississippi Sound, several rivers besides the Bonnet-Carré Spillway. As you can see in this figure, the urban areas are predominant throughout the Mississippi coast, and of course along or all of the Lake Pontchartrain surroundings. So urban area and also urban pollution is also a problem. Therefore, it is necessary to characterize the circulation of pollutants throughout the Mississippi Sound. And for that, we require first a hydrodynamic model. Of course, to develop this hydrodynamic model, we need to make a comprehensive analysis of observed data, including salinity, nutrients, coliforms, suspended solids, and chlorophyll A. And that's what we've done to provide a geographical container to our hydrodynamic model. For example, we have looked at salinity data collected by the USGS, the United States Geological Survey. The USGS has several stations located offshore and also close to the coast, not on the coast, but close to the coast. along with a station in the Rigolets, this natural canal. And we can see that in 2016, when the hydraulic structure, when the spillway was opened, the decrease in salinity in the regoliths in this location was sharp and fast. And also in an offshore location like Grand Pass, that is about here, I will take this away. Grand Pass is located here in an offshore location that is close to the Lake Pontchartrain and close to the spillway. We have also a sharp salinity decrease. In a location that is eastern, in the eastern part of this figure, we also have a decrease in salinity, but not as sharp as in the western locations. But we can see an immediate effect of the opening of this spillway in the salinity of the Mississippi Sound. So if we take a look at data from coastal water quality stations, we can also see that effect. For example, this is the 2016 spillway opening, and in coastal stations that are along the Mississippi Gulf Coast, we see a decrease in salinity that goes until later in the year. And also we also see a decrease in 2018 when the spillway was open around 22 days. We see this sharp salinity decrease, especially in the stations that are close to Lake Pontchartrain, that is here in the western part. And for example, in 2019, where the longest spillway opening took place, we have a really sharp decrease in salinity in all of the stations along the Mississippi Gulf Coast. And in this year, the consequences for biological species in the Mississippi Sound were devastating. And of course, if biological species are killed by these openings, also the economic activities, fishing, etc., that depend on the biological species that live in the Mississippi Sound are also strongly affected. We have also taken a look of water quality effects in the Mississippi Sound. And as you can see, the effects in the increasing concentrations of several pollutants is evident during the 2019 spillway opening. Perhaps the most important increase that we can see here is of chlorophyll A, because several algal blooms occur due to the opening of the spillway, and also phosphorus and nitrogen that were also increased excessively due to this spillway opening. So with all of that analysis of observed data, we have come up with this hydrodynamic model that covers, of course, Lake Pontchartrain, most of the Mississippi Sound, and we have implemented this eastern limit, just taking a look at this data, that for eastern stations, the consequences around this longitude are smaller than for western locations. We have, after doing all of this analysis, We have developed the computational grid and also the hydrodynamic model using the environmental fluid dynamics code, the commercial version. And we have implemented all of the freshwater boundary conditions, or the lakes, the rivers that drain to the main rivers that drain to the study area, also the Bonnet-Carré spillway. And we have also provided ocean boundary conditions that allow the computational grid to use ocean data in the simulation. We have began the calibration of the model, and we see that, for example, in the middle of the Mississippi Sound, our model is more or less predicting consistently with observed data, although we are overestimating a little bit. At the regoliths, we are hitting the mean salinity concentration and also the mean water elevation values. We are missing the maximums and minimums of this hydrodynamic behavior. But of course, these are results that were simulated when we were doing the paper. So we are a little bit better now. And in the eastern location, in the most eastern location, we were still overestimating water surface elevations. Nevertheless, since in the central Mississippi Sound and also in the regoliths, our simulations are acceptable, we tested the model to see if it generates data consistent with what we have observed historically in the Gulf. We have simulated the longest spillway opening, the 43-day spillway opening of 2019. And for example, when we use 100% of the flow that was introduced from the Mississippi River to Lake Pontchartrain, we simulated salinities, concentrations along the study area, and we see that we achieve the decreases in salinity along the Mississippi Sound that are at least qualitatively consistent with observed data. Since we saw that this was making sense, we also said, okay, let's try to find the flash time of the lake depending on the inflow from the Bonnet-Carré spillway. And we decreased this inflow in 25%, 50%, and 75%, so that we can see how the flashing time of the lake is affected with the increase or decrease of the inflow from the spillway. And we found flashing times that are consistent with what was reported in the literature. So our model is more or less replicating what was reported in previous researches. Also, since we were having at this time an acceptable model, we implemented a pulse, not a pulse, but a constant concentration of total phosphorus of 1 milligram per liter coming from the Mississippi River through the spillway, and also simulated this for years for the spillway openings of 2016 and 2018. And we also achieved results similar to what was observed, especially along the coast of Mississippi. That is the increase in total phosphorus that I mentioned previously when we were looking at the observed data. So I think as conclusions, we can say that studying the observed data, the water quality observed data, and salinity data allowed us to generate a good hydrodynamic model that is able to replicate flushing times reported in the literature, and also simulating total phosphorus transport throughout the Mississippi Sound that is similar to what was reported by observed data. The next steps are, of course, improve our calibration and maybe validate our model with additional historical data, and assess the necessity of hydrological modeling of coastal watersheds, the watersheds that drain to the Mississippi Sound, or extend the computational grid of our main rivers, and maybe also additional statistical analysis. With that, I thank you very much for your attention, and I wonder if you have questions. Thank you.
Thank you very much, Vladimir, for your presentation, for this very, very interesting paper and presentation. Okay, is there any question concerning this paper, this presentation? Okay, so apparently no question, because well, it was very well described and presented, and it's a very interesting paper simulation. So thank you very much, Vladimir, for your.
Thank you, Giuseppe, and please please send my regards to Beniamino and Helmut.
Sure.
Yes, he's here.
Hartmut is actually here. Oh my God.
Hey. How are you, Helmut?
I'm Vladimir.
Long time no see.
Yes, a long time. Hopefully sometimes in presence, huh?
Yeah, maybe next year I will join you physically.
Great, let's hope. Yes, very good. Would be great.
And please, also, I know about the Carmelo.
Yeah.
And
that
please, he was a very nice person. He spoke perfect Spanish, and please send my regards to his family and tell him that.
Thank you.
That,
Thank you very much.
Thank you very much.
The loss.
Okay.
Thank you.
Here, and see you soon.
See you.
Bye-bye.
Thank you, Vladimir. Thank you.
No, I will stay in the presentation. So.
Okay. Great. Thank you. Okay. Thank you, and we'll leave room now to know who is presenting, because we have Wilson Marcelo Fonseca Torres, Marcelo Leon, David Almeida, Franklin Rodriguez, and Fabricio Echeverria. Possibly I misspelled all of the names, and I do really apologize for that.
I think it's missing.
Okay, nobody's missing. Okay, we got not this presentation. So we have, however, okay. So the papers that were actually listed in this session have been presented, and I do thank you very much for your presentation. We have a further paper to be presented, and by Huang Nguyen, and I thank you very much for your patience for assisting here. Huang actually wasn't scheduled for this presentation. She was actually enlisted in a previous session, so I thank you very much for your patience. I think that, and I leave you the floor. I have your presentation. So if you'd like to share your screen and to present us your findings, they will be more than welcome. And thank you very much. The floor is actually yours. Okay.
Is me present now?
Yeah, sure.
Oh, okay.
Sure you can. Okay.
Oh, wait.
Can
Yes,
you
yeah, we see. I see your screen.
okay. I'm ready.
You can go.
Yeah. Hello, everyone. I'm her, and I'm excited to be here to share our research on diagnosing kidney eye and skin disease using advanced AI technique. And early detection is key to protecting drug vision and health, and our study interview and improve approach to this challenge. And here we have 6 sessions and the embracing relevance of dermatological and ophthalmological disease in drugs pose serious health risks, including chronic discomfort, infection, or even permanent damage if not treated early. And traditional diagnostic methods mainly rely on visual examination by veterinarian, which can be subjective and inconsistent, especially in remote or under-resourced areas. And while recent AI models like YOLO or CNN have shown promise in medical imaging, challenge remain in capturing subtle features and generalizing a broad, complete veterinary case. And early and accurate detection is crucial for timely treatment, reducing suffering, and improving the overall quality of life for affected animals. And here's a quick summary of recent EAP study in animal disease diagnosis from 2020 to 2025. As we can see, model like factor or CNN or tiny yellow version 4 to really high accuracy up to 95%, and it's impressive, but despite that, its story still has clear limitation. And some are too computationally expensive. Some only work on specific body part like pores, or others still need clinical validation. And this shows that while deep learning information and it's still not fully ready for real-world veterinary use, and that's why our study built on this by using Euro version 11 compiled with multiple augmentation techniques and aiming for better generalization, higher accuracy, and more practical deployment in real clinical setting. And next, I will explain the methodology used in this research. For our model training, we use two publicly available datasets, one from Medley data for skin disease and one from Global Universe for eye disease. And the skin disease include for class bacterial dermatosis, fungal infection, healthy skin, and hypersensitivity or allergic dermatosis. And the eye disease dataset cover 5 common conditions: cataract, cherry eye, conjunctivitis, glaucoma, and iris atrophy. And together, these dataset offer a diverse range of label image, helping us train a more robust and comprehensive diagnostic model. And or image here will resize to 640 by 640 pixels to maintain consistency and optimize your vision 11 performance. And standardization ensure efficient computation and compatibility with object detection algorithm. And you can understand this step through the image here. And to improve model robustness and reduce overfitting, various annotation methods were applied, such as rotation, blipping, brightness, and contrast adjustment, or arc Gaussian. And these steps ensure the data is balanced, diverse, and robust, allowing the model to generalize effectively in real-world scenarios. And after the conventional method, we implemented more advanced augmentation techniques like LPP and CODMID. About LPP, we convert it into grayscale, and for every pixel, we encode its intensity relative to its neighbor. And this process generated a histogram that captured key texture pattern. And by doing so, the model became better at recognizing skin-related abnormality, often rely on 5 range texture difference. And about CODMID, we also apply CODMID augmentation to randomly releasing a bag in one image with a peg from another image, and we updated the label accordingly to reflect the mixed
region. And the key benefit here is that it increases data diversity and help the model generalize better, especially in cases where lesion or disease might only appear in small part of an image. And part of this technique, ABB in combination with essentially helping us bring a more balanced and diverse datasets, ultimately improving the model accuracy in diagnostic basking and IDCs. And in our model, we use two main components in the model architecture, like YOLO version 11 and autoencoder for feature extraction. And first, let's talk about YOLO version 11. YOLO version 11 has two main parts. Is the backporting with extract important feature from the image using convolution layer, and the hash with process the feature to make accurate detection, and compare to reverse version. Version 11 includes several upgrades like the C3K2 block, which improve how efficiently features are extracted, and the SPPF module which speed up processing time, in the C2BSA log would help the model focus on key area in the image, and plus the issue and uncovery design, making the detection process faster and simpler. And now for the autoencoder, it has improved detection accuracy by learning complex but meaningful image feature, and it include an encoder with convolution layer of increasing depth to capture key pattern, and decoder with a reviewed image from those complex features, which are the autoencoder on 128 by 128 made for 20 epochs using L1 lots and the HD optimizer. And one strain we use the encoder part to fit a better feature into YOLO version 11 would help the model detect IDC more accurately, especially in complex cases. And so to evaluate how well different augmentation strategy perform, we train 12 model variation. We start with a baseline using just the original image. Then we gradually apply different combination of autoencoder, or cut meat or ABB individually and in sequence. And for example, we try original image with a cut meat or ABB followed by autoencoder, and even full combo original ABB cut meat and autoencoder. And each version was tested to see how it impacted detection accuracy, especially on complex image. And here a quick look at the full training pipeline. We start with import image, skin or IDC sample. After resizing and basic reprocessing, we apply three techniques like autoencoder to extract meaningful feature, or ABB for texture enhancement, and commit to improve data diversity. And this output then confined in fact into YOLO version 11 for training. And the goal here is to identify which combination bring the highest accuracy while still being report about different datasets. And after building the train pilot, we train the model using GPU to speed things up. And we apply early stopping to avoid overfitting and keep the image size consistency for better learning. And the model was optimized to balance accuracy and stability, making sure it worked well across both skin and IDC cases. And in this study, we mainly evaluate our model using MAP 50 or mean average precision at 50% IOU. And this method tells us how well the model can localize and classify lesion, which is really cool in the disease detection task. And we compute it by taking the average precision overall disease class. In our case, that 9 different conditions. And you can see the table shows the result from 12 different training setups using different combination of data augmentation you don't have look at every number, but here I'll highlight the baseline model which you only the original image, 88.7%, and but up to 98.8% when tested on complex image. And the top perform model is the last one, which compile original LPP cosmic and autoencoder is rigged 97.2% on original and 86.6% on complex data. And also, were not to even short commit, autoencoder we all along gave a 9 push reaching 67.1% on complete image. So clearly different augmentation strategy can make or break model performance. And from this result, we can draw some key conclusions. And the baseline model work fine on standard image, but really struggle with harder, more diverse cases. And the best performance came from combining on three techniques like LPP, cosmic, and autoencoder. We have the model handle both simple and complete data better. And interestedly, commit autoencoder alone already make a big impact on generalization. And for the LPP online model, they were very at detecting button in texture in hand image, but didn't generalize well to real-world complexity. So overall, hybrid augmentation is not just helpful; it's essential for building robust model. And besides augmentation, we also noted a few other important challenges. First, a lack in imbalance. Some conditions like battery dermatosis had way more image than real one like cherry eye. This may cause the model to perform poorly on minority classes. And in the future, we can try balancing method like oversampling or using focal loss. And from a veterinary perspective, this research showed that AI-based augmentation can really improve disease detection, especially in early stage. And as for future work, we want to push performance on complex image and tackle that implant directly, and more importantly, that test this model in real-world setting with actual lineage data. And it would help bring AI to the lab to real veterinary practice. And so after analyzing the result and key findings, let's wrapping up with a quick conclusion. In this study, we refer an AI-based diagnostic framework for canine eye and skin disease using Yellow version 11 in hand with three key techniques like CODMATE, LPP, and autoencoder. And this combination proved to be really effective, especially when used together. And the best performance model using on 97.2% maybe on the original image and 86.6% on complete image, clearly outperforming the baselines. And the results show that deep learning, when combined with smart augmentation, can greatly improve diagnostic accuracy and robustness, even in tough real-world conditions. And looking ahead, our future plan is to refine this framework further, explore new augmentation, and more importantly, test the system in real veterinary setting to have support faster and more reliant disease detection for our further patent. Yeah, and I truly appreciate the researcher and dataset creator who work with sensor to this study. Their valuable effort and result have made this result possible. Yeah, that concludes my presentation. Thank you for your time and attention. Yeah.
Thank you very much, Paul. Thank you very much for your patience and for your presentation. I don't know if there is anybody willing to ask some question. Okay, so thank you once again. Thank you everybody for being here today, for your presentations and for participating to this session. Okay, thank you, Simone, for your support here. And okay, thank you very much once again for this afternoon. I think that we are done. And okay, so for those who are here, we'll see each other tonight. Unfortunately, not with people online. And so, all the best, and I wish you a very good continuation of ICCSA works. Yes, and I know that the proceedings are online, so you can access your profile on ICCSA website and download the full proceedings. And okay, this is a good thing that we managed to have our papers published and available during the conference. Thank you very much once again. Thank you.